Hello, I am Darrell Quarles, the senior author on this paper entitled Structural and Functional Evidence for Testosterone Activation of GPRC6A in Peripheral Tissues. In this manuscript, we have tackled the controversial area of the mechanism underlying testosterone's rapid membrane sensing responses, sometimes referred to as non-genomic effects. This project represents efforts of a team of investigators that use complementary approaches to test the possibility that GPRC6A is a physiologically relevant testosterone sensing receptor. This slide represents the salient features of our study. We found that testosterone activates GPRC6A in vitro. We also found that testosterone regulates insulin secretion in beta cells, as well as regulates the enzymes responsible for testosterone biosynthesis in Leydig cells. All of these effects were mediated through GPRC6A dependent mechanisms. We also found that testosterone directly binds to GPRC6A in target engagement studies, and through our collaboration with Oak Ridge National Laboratory and UT Knoxville, we found that the structural basis for GPRC6A binding to testosterone.
My name is Min Pi in Dr. Kaur's lab at University of Tennessee Health Science Center. In this slide, we show testosterone stimulates cyclo-AMP accumulation and ERK phosphorylation in hex cell trifecta with GPRC6A cDNA. As shown in this slide, we find that testosterone stimulates GPRC6A mediate insulin secretion and expression of enzyme responsible for testosterone biosynthesis in vivo and ex vivo. In this slide, we got that testosterone directly binds to GPRC6A by saturation analysis.
Okay, I'm Jeremy Smith from the Center for Molecular Biophysics at Oak Ridge National Laboratory. And in this project, what we did was structural modeling of the GPRC6A, a G protein coupled receptor. This is three-dimensional structural modeling. We constructed a model. Karen Kapoor, who was a graduate student, and Jérôme Baudry, who was an assistant professor with us, now he's an associate professor. And what we did was to build a three-dimensional model based on known crystallographic structures of GPCRs, and then we docked testosterone into the model to find out where it might bind computationally using physical models. So a binding site was found, and then what you need to do is to verify experimentally whether this is true or not. So the team in Memphis made some mutations suggested by the modeling, and if the modeling is correct, that should disrupt the binding of testosterone. Indeed, that happened, so that validates the model and shows that probably we've got the correct binding site for the testosterone in GPRC6A.
I'm Ramesh Narayanan here at the Memphis campus of the University of Tennessee Health Science Center. Based on the molecular modeling, we designed molecules that selectively bind to GPRC6A but not to androgen receptor. DJ1267 is one of those molecules that's shown here in this figure, and it has a chiral center that can be derived as S and R isomer. The S isomer binds to the androgen receptor and activates the androgen receptor, but the R isomer failed to do so. However, we found that the S and the R isomers both activated GPRC6A as shown here by insulin secretion and by phosphorylation of ERK. These molecules will become the first-in-class GPRC6A selective agonists.
I'd like to thank all of the co-authors and especially Drs. Newgard and Rouse for kindly providing study materials, and NIH and American Diabetes Association for supporting the work. Please read the paper for more in details. Thank you for your watching.